and is truly one of the leaders in fabrication. What you may not know is that Bill used to be a boat builder and a boat racer before building and fabricating great buildings and works of art.
Thanks, Lon. Yeah, our motto is anything but boats right now. No better way to ruin a hobby than to do it for a living, or at least in my case. So thank you all for coming. Thanks also to the sponsors and the exhibitors for being willing to roll a dice on something brand new and show the kind of spirit that this whole sort of talk is about. And thank you for coming and doing the same. My presentation is really about kind of my little company. We're up in Napa now anyway, and we've been in business for 33 years, as Lon said, and we started as a result of the company I was working for being sold and me not having a job. And since I'd never really interviewed for a job before, I knew that wasn't gonna work. Nobody'd ever hire me, so I had no choice but to start my own business. And I took what I knew about composites, and I took a stack of credit cards that I had that I'd managed to have a little bit of room on, and I took a little teeny bit of the company that I'd worked for, that I owned, and bought the old woodworking tools, and started a little business making composite products or reinforced plastics. And so time went by, and fairly quickly, not too long after we started in 1982, we got an inquiry from an architect to do a project with them in Japan. It was a theme park, and one of the things they wanted was a 33-foot tall version of a gas station attendant, which I said, sure, no problem. I knew how to do that because I had a friend who was working at the Monterey Aquarium at the time that had built this big whale, and I'd watched how they did that, and it's simple. You just take the, whoops, that jumped past where I wanted to be. You jump past the, there we are. You take the little model and you take it over to your bandsaw and you saw it up into slices. And if you're careful and you get the slices just right and you get thin enough so that you get pretty good resolution, then you take it over to the other thing, which is the opaque projector. And you put the slice on the opaque projector and you back up far enough so that the projection on the wall gets big enough so that it sort of matches the size that you want to make your gas station attendant. I mean, that's all there is to it. Then you pin on the wall a piece of foam of the appropriate thickness, and you draw the shape, and then you saw it out with a saw, and there you go. You stack them up, shape the edges, and you've got a sculpture, except we didn't have a clue how to be sculptors. I mean, we're just kind of like boat builders. And so we thought, well, we got to get a lot of thin slices, right? I mean, you can't, we got to get slices like an inch thick so we can just kind of connect the dots. Trouble with that is the bandsaw blade was so thick that it turned it into rubble. By the time I'd end up with a bunch of sawdust and some weird, strange-looking gnome that looks sort of like So we decided, I got to figure this out. And I was thumbing through a sculpture magazine, and I ran across a picture of an ad for a little company that was down in Monterey that had invented this thing called a cyberware scanner. And they had used it to do motion picture stuff. They had done the water tentacle in the movie The Abyss, using this to capture the facial features of the actor. And they were exploring other uses for their little machine, and they were thinking maybe sculptors could use this information. And so I had found that while I was really looking for a place where I could buy a really thin bladed bandsaw. And my plan was, okay, so I talked to these guys and they said, well, yeah, you don't have to cut it up. We'll just scan it and we'll have all those cross sections every millimeter apart if you want. And that would have been just perfect. So I said, great. I'm gonna send you this model, you guys scan it, and then you take all those cross sections and you print them out on typing paper so I can put them in my opaque projector and I can put them up on the wall. And now I'm down to 1-inch thick slices. That I felt like we could probably figure out how to do. So let's see, get back to where I wanted to be. So I did that, and he said, well, you know, that's about the dumbest idea I've ever heard. He said, why don't you use a CNC machine, and since all this information's digital, you can just cut out the slice with a CNC machine. Well, I had no idea what a CNC machine, and I'd worked in my godfather's foundry when I was 13, so I thought I knew all there was to know about machines. I went to the machinist's handbook, which is a book about that thick. It was a couple thousand pages of fine print at the time, and I found one paragraph on CNC. And it was like, you know, this is gonna happen someday. But the sign makers, the guys who were making signs, who were customers of ours at the time, were using these to cut out lettering. I called them, I said, could you cut them out? And they said, no, it can't cut out 1-inch foam, it can only cut out vinyl. So sticky back vinyl for making letters. But anyway, we decided maybe we just better make our own. There's the 286 IBM PC with a AutoCAD Lite stack of cross sections, which I was going to print out. So we went and we said, okay, well, let's see if we can't make our own CNC machine, because I couldn't buy one. And I had a little bit of money left on my credit cards, and I set a budget of $16,000, which was the profit on the gas station man plus all the credit I had on my cards left. And I discovered that there was a company called CompuMotor up in Roanoke Park. They made these little servo motors that they could use to control, you know, a computer could control the motion. And there was a company called Linear Industries, a catalog company. You could buy rails and stuff. And then, of course, there's Orchard Supply, which was our local hardware store. And with those three, now today that's called lean manufacturing, you know, reducing the supply. This is our first CNC machine. It's plywood. It has a Bosch die grinder as the cutting tool, and a router bit to cut out the slices, and an air cylinder, raise and lower it. So it's really just a 2-axis router with an up and down motion on the cutter. And for years, and there's the Cyberware laser scanner, for a long time, we made stuff out of 1-inch thick slices. I called it Petaluma stereolithography. And there's the gas station attendant leg materializing out of the foam. We figured out we needed to cut through the foam, but not all the way. Because once you did, where the hell was, you know? So we left the foam in the square. We used the edges of the square piece of foam as an indexer. We glued it all together, and then we broke off the excess scrap. And that, lo and behold, out comes a foot. And there's the gas station man. And I was over there not too long ago. And thank you. Thank you very much. We're actually, my wife says, you're not going to show the gas station man. I'm proud of the gas station man. So he's doing fine over there in the mountains of Japan. And you know, the fellow from the UK with the milking sheep. We were in a dairy farm, so maybe there's some connection between. Anyway, there's some more stack stuff. There's another thing we made. That gives you a little idea of, you know, not too much sanding needed. There's Miss Piggy. That's the mannequin for Miss Piggy for the costume that Disney wanted. Dinosaur. We did a lot of dinosaurs. And then Klaus Oldenburg, the rather well-known pop artist, came to us with a sculpture that he wanted to do. And he wanted us to make the patterns for the aluminum castings to make the tie. And he heard about our scanning. So we said, well, we could do that, except that we need you to give us a model. And he said, well, you know, I've got a model. It's really what I want it to be, but it's not thick enough. We can't get the engineers are telling me there's not enough room inside to put the stainless steel armature. So knowing a little bit about composites, I said, well, why don't we just do it out of composites and forget about the stainless steel armature, and we'll use the skins as the structure. So we had a little finite element program, which is fairly new at the time, and a structural engineer that we work with that did this kind of thing. And he modeled it and convinced the German government, the code officials in Frankfurt, that it was going to work. And we set about starting to make this sculpture. And again, all out of 1-inch thick slices. There's the artist and his wife, Kosha, inspecting the collar. There's the piece getting ready to ship, and there's the piece in Frankfurt in front of the DG Bank building. We took that idea to the next level, and we started machining, instead of using the foam to stack up and make the object and cover it with fiberglass, it occurred to us, well, rather than use the foam part, let's use the scrap. We'll put them together, and that'll be a mold. So we molded these pieces in those one-of-a-kind molds out of fiberglass. And this is a piece called the house ball. It's a series of blankets wrapping up what's supposed to look like a bunch of your earthly possessions. And that's in Petaluma. That's the finished part. And in the foreground, you see the little plaster model. In the background is the finished piece before the final coating. And there it is in Berlin at Checkpoint Charlie. It's part of the collection of the American Embassy. Then Robert Graham came to us with a sculpture he wanted to carve out of stone. And of course we said, sure, no problem. Give us the money. But this was too heavy to do any other way, and we couldn't, so we decided we needed to make a new machine. We needed a machine that would basically take a big heavy block and turn it around on a turntable, and maybe have an X and Y arm going up and down, and then what we got to do is figure out how to cut stone. And we looked into all kinds of things and finally decided that a diamond-bladed chainsaw would do the job. So we looked into that, and sure enough, some guy came out and sawed the curb out in front of the shop in half for us to show us how wonderful it was. The only problem was these damn chainsaw blades cost a fortune, and we figured he gave us a little calculation on the number of chainsaw blades we'd need to do this job, and it was like twice the budget for the whole job. So forget that. We went back to the artist and said, we'll take the stone, grind it up into a powder, mix it with resin, and we'll cast it out of a cast stone. We'll need a female mold, so we need a male pattern from which to make a female mold. And by then we'd already started making this stupid machine. And so we just carried on. The machine has basically got a tower crane bearing with a plywood top on it, and it rotates around. And then next to it are these two giant steel columns, in between of which there's an arm that goes in and out with a motorcycle chain guiding it up and down. Some people use ball screws. We use motorcycle chain, works fine. And then the cutting tool is just a piece of shaft log, drive shaft shaft material, hardened steel, basically turned down a little bit on the end, and then we dip it in epoxy, dip that into crushed aggregate, and that becomes an abrasive, and that was the cutting tool. And so, it worked fine. And then we made a female mold off that foam, took the foam out with a sandblaster, and then cast the part. And that's down in San Jose. That's in the sort of central courtyard of this, right down in the middle of town. Converted milling machine, and then we also made a bigger 2-axis machine that we actually made into a 3-axis machine. So we've got a 4-foot Z-axis, so we could do more complicated shapes. This is pattern for a mold for the cowling for the JLG, those construction machines. Then we thought, well, we can make it into a 4-axis machine. We'll put a rotary axis on it, and we can turn something. And so this is a pattern for a bronze casting for a sculpture that is in Central Park Central Park East, at the north end of Central Park. It's the third of the 4 corners that has a sculpture. It's the Duke Ellington Memorial, and it's by Robert Graham. And we did the columns, and we did the statue of Duke, all using laser scanners and CNC machines. The trick we had was that we didn't care so much about super precision. If we could be within a millimeter or two, if we could mimic the accuracy of a good cabinet shop, there's a big market for the ability to do this kind of thing that close. And so because of that, we could get away with motorcycle chains and tower crane bearings and Dayton motors and Bosch die grinders. There's another machine. There's the first real machine. We actually bought that one. It's a 5-axis machine. Then things, over the years get more complicated. This is a rock formation that we scanned. That's the model of it. This is the rock formation itself. That was the casting in poured-in-place concrete from molds that were the negative of the scan data that were made out of foam and used as form liners for the casting. So more stuff on and on. And this is at the Denver Convention Center. This is called, I See What You Mean, is the sculpture. But he's looking through the third-story window of the convention center. He's all composite. This is up in Sacramento. This is at the airport up there. This is all aluminum, actually. This was cut out by a friend of mine up in Tacoma that has a boat building company making Coast Guard boats, and they had a little time on their two-axis or their aluminum router, and they cut out like 3,000 pieces of aluminum for us in, I don't know, a day or something. This is a job we did fairly recently at Stanford. This is the new Stanford Bing Concert Hall. It's a performing arts arena, and it's actually Turner Construction was a general contractor, and they're going to be giving a little talk later. So they'll talk maybe a little bit about this and other things they're doing in this area. And then this is our latest project. This is the new addition to the San Francisco Museum of Modern Art. This is the building facade for the SF MoMA. And this is all composite materials. It's the first time composites have been allowed on a high-rise or a mid-rise building due to some fire code issues that we managed to pass, fire testing. But this facade required 700 panels to make up that facade, no two of which were the same shape. And so there's 700 molds for 700 parts. This would not be you could do it by hand, but it would be decades of handwork. And we could make 4 molds. The molds are about 5.5 feet wide and 25 feet long, or average each. And we do 4 of them at night. We get the tool, the bed of our 65-foot mill set up, and we'd program it, and we'd turn it on, and we'd go home, and we'd come back in the morning, and there'd be 4. Well, not every time. And there is our latest addition. It's a KUKA 6-axis robot with another axis, a rotary axis, so it's a 7-axis robot. And we're trying to figure out how to talk to it a little bit more transparently. The workflow, right, Carl? And so that's the story of how you get into this thing using digital tools, a couple of credit cards, and not enough sense to know you're not supposed to be able to do these things. Thank you very much.